Let's just dive right into this explainer. Forget the Hollywood blockbuster versions of the big one for a second. We're going to look at the actual boots-on-the-ground geological science and the frankly terrifying infrastructure reality we're facing out on the West Coast. I know, we hear about the San Andreas Fault literally all the time, right? But the actual mechanics of how it breaks and what that means for the millions of people living right on top of it, well, it's a story of incredible geology and a ticking clock.
So we really have to start with this absolutely staggering statistic, 99.9%. According to recent studies using GPS and airborne radar data, there is a 99.9% probability of a 5.0 magnitude or greater earthquake striking the Los Angeles area within the next 3 years. Let that sink in. Researchers found these deep layers of the Earth are just holding on to massive amounts of pent-up seismic strain that absolutely has to be released. It's really not a matter of if anymore, but exactly when.
Now, you might be wondering, why is this pent-up strain quite so dangerous? Well, we have to ask what physically happens to the Earth when these massive geological stresses finally reach their breaking point. Remember, the fault isn't just some line drawn on a map. It's a massive, deep slice into the Earth's crust where friction is barely holding tectonic plates together. I love how geophysicist Dr. Julian Lozos describes this. He points out that the fault doesn't just snap all at once everywhere. In the shakeout scenario, which, by the way, is the absolute gold standard for earthquake modeling, they predict the rupture starts way down south near the Salton Sea and then literally unzips toward Los Angeles, like a zipper on a jacket, just ripping open really, really fast. It builds up this terrifying amount of seismic energy, kind of like a snowball rolling downhill, and directs the absolute most violent shaking right into the heart of the city.
Section 1. Anatomy of the Big One. Let's unlock the San Andreas and look at what makes one part slide while another part stays dangerously stuck. Scientists have actually gone to incredible lengths to understand how this works. The San Andreas Fault Observatory at Depth, or SAFOD, literally drilled a borehole 3.2 kilometers straight down into the active fault. Talk about getting up close and personal with the monster's DNA, right? Down there, they identified these very distinct zones. Creeping faults that are actively, slowly sliding, and locked faults that are stubbornly just holding on to all that immense tectonic stress. And part of this secret, it actually lies in the dirt itself. Geologists over at Utah State University studied this material called red clay gouge from the southern tip of the fault. What they found is fascinating, and honestly kind of ironic. Even though this super fragile material is less than a mile below the surface and only contains about 30% clay, it's mostly quartz and feldspar, it's actually that tiny bit of clay that effectively dictates how this massive tectonic fault slips and behaves under pressure. So here is the absolutely crucial point when comparing these sections. The drilling data shows that the creeping sections of the fault, they slide relatively smoothly. Why? Because they're filled with these weak, magnesium-rich clays that act almost like a natural lubricant. But right next door, you've got the locked faults. These are made of super strong wall rock with massive friction. They experience what geologists call velocity-weakening behavior. Basically, they stick, they build up catastrophic tension over decades, and eventually, they slip violently. Section 2, a synchronized seismic nightmare. Because, unfortunately, the geological data shows the San Andreas doesn't always act alone. If you thought one massive fault rupturing was bad, get a load of these threat multipliers. Marine geologists studying deep-sea sediment found that the huge Cascadia subduction zone up north and the San Andreas have actually synchronized in the past. Yeah, they've ruptured just minutes or hours apart 3 different times in the last 1,500 years. And it gets worse. Researchers digging into the Lytle Creek Ridge found the San Andreas shares about 20 to 23% of its earthquakes with the neighboring San Jacinto Fault. This essentially means a major quake could spark a chain reaction. We're talking a cascading supercycle of destruction, with a flurry of massive aftershocks as stress violently redistributes across the entire West Coast. Section 3. Severing the water supply. A city shaken dry. This is where things get really, really scary. See, the ultimate plot twist in this earthquake scenario isn't just the shaking earth or the collapsed buildings, it's what happens to the region's most precious resource, water. Los Angeles is basically a desert metropolis, right? They import roughly 88% of their water through 4 main aqueducts that were built over a century ago. The big problem here? Collectively, these vital lifelines cross the San Andreas Fault zone in 32 different places. A massive rupture will instantly sever the very arteries the city depends on, draining the lines and leaving millions of people literally without running water.
Just take the Los Angeles Aqueduct as one example. It relies on the deep, 5-mile-long Elizabeth Tunnel right underneath the Angeles National Forest. Because it sits 250 feet underground, exactly where the aqueduct crosses the fault, damage models predict a big quake could split the tunnel 10 feet in opposite directions. 10 feet! It will take an estimated 18 agonizing months just to repair this single critical choke point. 18 months.
Now, you're probably thinking, okay, but surely the city has backup plans, right? Well, when we look at the Department of Water and Power's contingency plans versus the actual reality on the ground, there is a terrifying lack of viable alternatives. The San Fernando groundwater basin, it's heavily contaminated with cancer-causing chemicals from historic Superfund sites. You'd have to massively dilute it just to drink it. The Metropolitan Water District reserves are vast, sure, but the outlet dams needed to actually move that water to LA aren't seismically sound and need like 15 years of upgrades. And the State Water Project? That aqueduct remains highly vulnerable to the exact same fault ruptures. LA's internal reservoirs hold less than a month's supply of drinking water. And remember, that single tunnel takes 18 months to fix. You can do the math on that one.
Section 4. Thirst and the Aftermath. Surviving the quake. How do you keep a city alive when the imports just stop? Well, just to the south, Orange County offers a surprisingly pragmatic blueprint. They built the world's largest water recycling plant. And get this, it's engineered specifically to withstand a 7.8 magnitude earthquake. They use a highly sophisticated 3-step process, pushing wastewater through microfiltration, reverse osmosis, and finally ultraviolet light. They clean local wastewater to create pure, drinkable water that is completely independent of those vulnerable fault-crossing aqueducts. The contrast here is just staggering. Because of that investment, Orange County has been safely drinking recycled water since 2008, producing 85% of its water locally. Meanwhile, Los Angeles remains desperately vulnerable. They do have plans for a massive recycled water program, but full operations have been delayed until at least 2056. Yes, you heard that right, 2056. And remember that 99.9% probability of a major quake hitting within 3 years? LA remains fundamentally dependent on imported water flowing right across a fault that we know for a fact is going to break. So as we pack our emergency kits, secure our bookshelves, and reinforce our homes, the science tells us the Earth will eventually shatter. But the infrastructure reality leaves us with a far more chilling question. When the San Andreas Fault finally unzips, will our greatest disaster truly be the shaking Earth, or the devastating, long-lasting logistical nightmare of a massive city without a single drop to drink? It's a reality we've got to face before the countdown runs out.